Hey everyone, and welcome. Today, we're going to do something really cool. We're building a predictive model completely from scratch. The mission? To use Python to predict a startup's profit just by looking at its spending habits. Don't worry, I'm going to walk you through every single line of code, step by step. Let's jump right in. So here's our game plan. First, we'll understand our mission. Then we'll gather our tools, get the data ready, actually build the model, and finally, see how well it did. Think of it as a complete builder's journey, from just a data file to a real working prediction engine.
Okay, first things first, the mission. Before we even think about writing code, we have to know why we're doing it. Nailing down the objective is always the most important first step in any data project.
The tool we're using for this is called Multiple Linear Regression. Now, I know there's an equation on the screen, but don't let it intimidate you. It's actually pretty simple. That y is just the thing we want to predict. In our case, profit. The x's are our inputs, things like R&D and marketing spend. The model's entire job is to figure out the perfect numbers for the b's, which tell us exactly how much each type of spending impacts the final profit. And this right here, this is our raw material, the 50_startups dataset. You can see we have our input features, the data we're going to feed the model, and then we have that single target variable, profit. This setup, with multiple inputs leading to one output, is a perfect use case for multiple linear regression. Our coding journey is going to follow these 4 simple steps. We'll get our setup right, then we'll pre-process the data, we'll train the model so it can find the patterns, and finally, we'll use it to make predictions. Every single piece of code we write is going to fit neatly into one of these stages. All right, let's get into it. Step 1, gathering our tools. Just like a chef lays out all their ingredients and knives before they start cooking, we need to import the Python libraries that are going to do all the heavy lifting for us. So this is our core toolkit. We're bringing in NumPy, which is our math whiz. Then there's pandas, which is amazing for handling our data in a nice, clean table. And of course, the star of the show, linear regression from scikit-learn. That's our actual machine learning model. This combination is pretty much the standard for any regression task in Python. Now for step 2, preparing the data. And let me tell you, this is probably the most important part of the whole process. Any model is only as good as the data you feed it. So we need to load it, check it out, and transform it so our algorithm can actually make sense of it. Our very first move is simple, but it's vital. This pd.readcsv command loads our data into what's called a pandas data frame. Just think of it like a super-powered spreadsheet. Then we just display it. Why? Well, it's a quick sanity check. We want to make sure everything loaded correctly and all our columns are there before we go any further. Okay, this next step is absolutely fundamental. We have to separate our inputs from our output. We use a function called ilock to do this. That first line of code grabs all the rows in every single column except the last one. That's our x, our features. The second line grabs all the rows again, but this time, only the very last column. That's our y, the profit we want to predict. Now the model knows exactly what it's trying to learn. And this brings us to a classic problem in data science. If you look at our state column, it's got text in it, New York, California, but our machine learning model is all about math. It has no idea what New York means. It only gets numbers. So how do we solve this? Well, the solution is a really clever technique called One-Hot Encoding. We bring in 2 tools for the job. One-Hot Encoder, which does the actual conversion, and Column Transformer, which lets us aim that conversion at one specific column. In our case, the state column. And see that remainder equals pass-through part? That's super important. It tells the transformer, hey, just leave all the other number columns alone. And boom, here's the result. That ct.fitTransformX command puts our plan into action. The state text column is gone, and in its place, we have new columns of 1s and 0s. A 1 in a column means the startup is from that state, and a 0 means it's not. Just like that, our data is 100% numerical and ready for the model. Okay, our data is prepped and ready to go. Now we're at the most exciting part. Step 3, building the model. This is where we'll split our data to keep things fair, and then we'll finally train the algorithm to find that hidden relationship between spending and profit. First up, we import train, test, split. This function is absolutely essential. It splits our data into 2 piles, a training set, which is 80% of the data, and a testing set, which is the other 20%. Think of it like this. We use the 80% to teach the model, but we keep the other 20% hidden away for a final exam. This stops the model from just memorizing the answers, a problem we call overfitting. That random state equals 0 just makes sure we get the exact split every time. And here it is, the main event. That first line, LR equals linear regression, basically creates an empty model, like an empty brain. Then lr.fit is the magic command. This tells the model, okay, study all of this training data and figure it out. The model crunches the numbers and finds the best possible coefficients, those b-values from our equation, that connect spending to profit. And just like that, the learning phase is complete.
So, our model is trained, but the big question is it any good? It's time for step 4, judging the results. We're going to take that data we held back, the test data, and see how well our model actually performs in the real world.
This one line of code right here is the payoff for all our work. We use the .predict command on our trained model, and we feed it the test data it's never seen before. The model takes the patterns it learned and calculates a predicted profit for every single one of those startups. Those predictions are now all stored in our pred variable.
And here's the moment of truth. We've put the actual profit values from our test set right next to what our model predicted. And just look at that. They are incredibly close. This isn't just random guessing. These are calculated predictions based on the patterns our model discovered. This is how we know our model is actually working really well.
So there you have it. We've successfully built and tested our own predictive model. Let's wrap things up with your next mission, locking in what you've learned today and figuring out where you can go from here. Let's just quickly recap everything you've accomplished. You built a complete multiple linear regression model from the ground up. You learned how to deal with text data using one-hot encoding, which is a critical skill. You now understand why we do a train-test split to build models that actually work. And most importantly, you saw the purpose behind every single line of code.
But hey, the journey doesn't stop here. I really want to encourage you to take this code and try it out on a dataset that you find interesting. From here, you can go deeper by learning about evaluation metrics like R-squared, which gives you a hard number for your model's accuracy. Or you can explore feature engineering to get even more creative with your input.
And I'll leave you with this final thought. Today, we predicted startup profit. But this exact same blueprint, this same process, can be used to predict almost anything you can think of. Housing prices, why customers leave a service, even medical diagnoses. Now that you have the tools, what complex problems are you going to solve?